Yeah, again, hi. I'm an architect at Rapid7, and I'm here to talk to you about software supply chain security. But I want to kick off with a quick story that starts with tin cans, the original containers. So tin cans were invented in 1810 by Philippe Gerard, based on work that had been done 4 years earlier by Nicolas Appert. Which was sealing food in airtight containers and heating it. And this killed the bacteria in the food. And they didn't actually know why it worked at the time, but it worked. So Nicolas did this in order to win a prize of 24,000 francs, which is about 50,000 pounds in today's money, that was offered by Napoleon Bonaparte, the ruler of France and one of the greatest generals in history. He knew that if he was able to secure his supply lines against food spoilage, it would let him revolutionize warfare. And this was one of the things that helped him to conquer most of Europe, until he stretched his supply lines a little too far into the Russian winter and they snapped. And that was the beginning of the end for Napoleon. Supply lines are just as important in engineering as they are in warfare, but we usually think of them in terms of supply chains, with one link handing off to another down the chain. Supply chain engineering is actually a whole complex discipline that uses machine learning and big data to optimize that path between consumption and creation, or other way around, sorry. So we, in software engineering, we have our own supply chains for delivering software and delivering value to our customers and our users. And like Napoleon, there are the key to our success, but they're also one of our greatest vulnerabilities. The primary supply chain that we're all concerned with as software developers is how code gets from our developers' computers to a production environment, to where a user can use it. This is the software delivery pipeline, which is an area that has seen some really radical changes over the last 10 years. We've had things like DevOps, continuous delivery, configuration as code, continuous integration, all cloud services, all these things have completely changed it, and it will almost certainly continue to change as time goes on. So a software delivery pipeline isn't quite a supply chain, but it's a good place to start thinking about how we can apply supply chain thinking to how we deliver code. So we'll start with a very basic idea of how our supply chain works. We have a developer, they create code, check it into a branch, it gets built and gets deployed to an environment. And we'll stick with non-prod environments for the moment just to keep things simple. Straight away, we can identify our first source on here, which is our developers. Now, the thing with sources is they can be trusted, you have to verify them. Our developers, we do trust our developers, setting aside the whole insider threat thing that none of us in security really like to talk about. But the other thing is that putting trust on your developers is actually putting a burden on them. And that is a mistake because you're making them your single point of failure. Anytime I see a news report about a big hack or a big breach at a company and they say, oh, it was all down to some intern who checked in bad code, I'm going, okay, so you have two problems. Number one, you have a problem in your processes that let people do that. And number two, you have a problem in your thinking that you think that's a real root cause. I believe that we should treat our developers the same way the intelligence community treats its most trusted sources, which is trust but verify. We believe you, but we're still going to check what you're saying. How we verify our developers is twofold. The simplest is that we use feature branches, and then those are separated out from our test branches. So if a developer checks code into a feature branch, we have a pull request and a pull to move over to the actual delivery branch. We have a second set of eyes on that for a peer review, and that way you're spreading the burden. Your pull request will also tie into automated testing. You won't be able to open the pull request unless your branch passes these tests that verify that your code does what it's supposed to do. And that would also include things like static security analysis, where you're running checks on your code to make sure that it actually doesn't have common security vulnerabilities. The second major source for our builds is library repositories. This is where we pull in all the code that other people wrote that we're going to use as part of our code. And in modern enterprise applications, this is 80 to 90% of the actual code in the builds we deliver comes as part of these libraries. This is where you get most of what people think of when you say software supply chain incidents. The big one, which started me on the path to this talk, is Log4Shell in the last year. And that happened 3 weeks after I joined Rapid7, and it was a bit of a baptism of fire. For anyone who hasn't heard of it, it was a vulnerability in the Java logging library Log4j version 2 that allowed attackers to execute code within your application if they were able to get your application to log it. So it was very easy to take advantage of, very nasty vulnerability. Within about a day of it being revealed, we were seeing it being used on a massive scale to attack servers all around the world. And people who owned these apps had to very quickly either patch up to remove the vulnerability or take the library out altogether. And the fun thing with this is, with a logging library like that, and with libraries in general, your dependency comes as a tree. So you might be pulling it in directly, or you might be pulling in another library that pulls it in that library. So it was quite nasty. One thing that we found when we were doing our incident response on this was a lot of people were going, well, we're using Log4j1, are we fine? And we're like, not really, because yes, you're not impacted by Log4Shell, but you have two major security vulnerabilities there, and you don't have a safe version to patch up to. And that's the second major issue that people hit with public libraries, which is crumbling infrastructure. Basically, as long as a library works, it's very easy to forget that, hey, we should be patching this, we should be updating to the latest supported versions, and all of a sudden you're using a version that's like 5 years past EOL, and when something does happen, you can't update to it. The third major issue that you run into with public libraries is licensing. This is more in the legal compliance side, but there's still something that you need to secure your supply chain against. If you're selling software to people, you do not want to be using components with a GPL3 license, or you will get into legal bother. The fourth issue we have to worry about is miners, crypto miners specifically. And that's an example of a type of attack that goes on where people load up malignant imitations of libraries to public repositories. So you might be looking for the Python library matplotlib, and they upload matplotlib in the hope that you make a typo and pull down the version, and they're able to steal your electricity and turn it into bitcoins. So those are the major issues we hit with the public libraries. What are the controls we can put around this? And this is usually referred to as SCA, software composition analysis. So there are various points in our life cycle, and this is kind of a digression from the supply chain, but we'll get back. There are various points in our life cycle where we can put in controls against this sort of thing. The first thing is before your build even happens. Pinning your versions so a lot of the build tools that are out there, like NPM, have this fun feature where you can just not specify a version and it'll pull in the latest version. And that does protect you against the whole crumbling infrastructure thing. However, it means that you don't know until you do a build what version you're actually going to be using. So the advice has pivoted in the last couple of years to actually pin your versions and make sure you're using known versions in there. And if you're using known versions in your code base, whether you have to pin them or whether it's just the default behavior of your language, that's where you can then scan your code repos and actually check, hey, what versions are you using? And there's a bunch of tools you can do this. The big advantage of this is you're getting coverage of your whole code base by scanning your code repos. With Log4Shell, this was our primary incident response, was just go in, use Sneak to scan all our repos, see everywhere we're using Log4j2, and then tell people they need to patch. And in fact, the fun thing with that was by the time we got around to scanning it, like the day after, about a third of our teams had already gone in and patched it because they work in security and they pay attention to the news. But that's the big advantage of this, is you are getting that full coverage. You're covering repos that you've forgotten about, that people don't explicitly own and so on, and you're just going everything. The disadvantage is that it is static scanning. So you don't know necessarily exactly what's going to be going into your build. This actually became a big factor with Spring4Shell, which was another big dependency vulnerability incident at the start of this year with the Spring library. And the problem there is that Spring sets the versions of the libraries within its framework by inheritance a lot of the time. So you're pulling in a POM file from another repo, which means if you're just scanning your repo, you don't know what versions you're going to be using. So that one we had to shift towards alternative methods. The most common alternative method, the most common method in general, is actually testing your dependencies at build time. And this is really good because you know exactly what's going into your build. It also fits right into the SDLC for people because you're used to, you do your build, you run tests. This just becomes another type of test that you do. And it's also the easiest to implement, which is why there's loads of open source tools you can use. There's commercial tools you can use. There's lots of fun stuff in there. The disadvantage of scanning at build time is that you're only scanning things that you're actually building. So if you have something that's sitting out in production and no one's going near it for 2 years, or then you're not going to know when a new vulnerability comes along. You can get the best of both worlds with post-build scanning your build and container archives, because you should be archiving all your builds and all your containers for trackability anyway. But if you're able to scan those repos, that is all your code that's out in production. That is the actual code that's out in production. And you can do some really neat things like say, oh, hey, every version we have up to version 1.3 is vulnerable. If you're past that version, you're safe. So it's really nice for being able to do that. The big issue with this one is just that the tooling isn't necessarily always there for it. For some reason, this is an area where there's kind of a gap in the market and it's not that well supported. Even things like I mentioned JFrog's X-ray tool there. I haven't had a chance to use the most recent version of it. At my previous job, I was using an older version of it and it was basically unusable because the UI was so bad. And it was a very powerful tool that you couldn't use properly. So this would be great, but if you're able to do it, but not everyone can. The last place, which is well outside the scope of this talk, is scanning your production environments for these issues. This is where I mention my employer's products because they're what we used when we were testing this down. I said, this is well outside the scope of this talk, but it does need to be part of your incident response because like using Insight VM was how we found out that the backup software on all our developer laptops was vulnerable to Log4Shell. So we were then able to go out and mitigate against it and then patch up to fix that. But it was an exciting afternoon. Yeah. So back to the build. All of that is talking about what's coming out of those libraries, but we also need to consider those libraries themselves as sources. And do we trust them? Do we verify them? In a lot of cases, the bigger libraries like Maven, NPM, RubyGems would say, yeah, we're happy enough. They'll give us, if we ask them for a library, they'll give us the right library. The problem is if your developers are able to go and reach out to arbitrary small repos or try and pull stuff, like do a curl call directly out to a server to get a file as part of their build process, then all of a sudden you've got arbitrary sources in there and they could be going to somewhere that they don't realize is untrustworthy. And again, we're putting the burden on the developers, which is not good to do because it's like we want to have guide rails. The way to secure against this sort of thing is actually to recognize that the infrastructure that your software delivery pipeline runs on is a production application. So treat it like one. Put a trust boundary in place, only let it call out to the IPs that you've allowed listed and so on. And that way, Maven is allow listed, so yes, it can pull in from there. Whereas if they're going to say dodgygems.org, then it'll fail. One way to handle it as well and to sort of insulate your developers from failure in this is by using a virtual repository. Like we have our public libraries, we also have our private libraries that we're building internally and reusing our code within. And the software that we're hosting that on will usually let you set up virtual repositories. A virtual repository is basically all the repo calls from your pipeline get directed to it, regardless of where they're trying to go. And then it has rules in place to say, if you're looking for a Java file, go to this repo. If you're looking for a JavaScript, go to this repo. Virtual repos also let you protect against a nasty little type of attack called dependency confusion. Dependency confusion is if I know you have an internal library called, say, like Megacore customer processing, then I can create a fake version of that, stick it out on NPM. You've got version 2.8. If I think you might not have your versions pinned, I can stick version 3 and your build tool will go like, oh, there's a later version available here. I'll just pull that down. Or I can match your version and just hope that your ordering will pull it from the wrong place. What virtual repos let you do is they let you actually specify, check the internal repo. If it's in the internal repo, don't check anywhere else, even if there's a later version, that sort of thing. So it lets you protect against that type of attack. So it's very nice. So that's our build done. Not the longest I've had to wait for a build to be done. We have a few more steps to do before we go to production. The one we care most about is containerizing. Containerizing is basically wrapping your build up with an OS and a virtual environment. So it's a container that you can run in very standardized environments. And there's some neat stuff you can do with that. And we'll actually touch on some of it later. For our purposes at this point, what this does is it introduces a new source, which is the library of those templates. And sometimes those will be public libraries. Sometimes those will be internal libraries where you've got your own custom templates. Key thing here is this is another place where you can have open source dependency issues because there'll be those libraries in there. You can also have issues where the OS itself has vulnerabilities come out. So your template is using one version of Unix and suddenly there's an issue with it you have to update. And this means that you need you need to track what version of template each of your builds is using in production. So if you get an updated template, they have to be rebuilt and redeployed. You need to have processes in place to do that. So again, this is where archiving, this is where being able to check is really important. The other key thing before deploying is actually deploying to production. And again, this is where your supply chain needs to be protected against compliance issues, because an awful lot of compliance frameworks will say, if you're deploying to production, you have to have the person doing that, either approving it or actually doing the deploy, is someone who doesn't have access to actually deliver code. So, and usually the way that'll be done is you'll just have two AD groups and you can't be in one if you're in the other or something. So now we're going on to production. Broadly speaking, there are two different types of production. The first is a storefront. And this is my favorite storefront. A storefront is where you're providing your code out to be consumed. So it might be we're putting it up on our website and people can download it. It's being burnt on a disk and sold in the shop, or we're actually delivering it to one of those library repos that I mentioned. The key thing to recognize here is the storefront is the end of your supply chain, but it's a link in someone else's supply chain and you become a source. So they need to be able to verify you. Common ways of doing this is you might sign your code with a certificate, or if you're putting your code up on a website, you might put, here's the hash of the code, so you can check that what you're downloading is what you're expecting to be downloading. The other thing you need to bear in mind if this is the type of production environment you have is more and more you're being expected to provide a strategic bill of materials with your code, or an SBOM. And for example, this is one of the areas that the US government is starting to look at. Every supplier must put an SBOM with their code. And that's just a list of all the things in your code that you didn't write. So that is all those public libraries, that is your versions from your container templates, all that stuff. So it's another reason why you need to track all that stuff and be aware of what's going in. The other type of production is what we would call a production environment. And that's where you have a production environment is secured and it should only have one fortified point of entry, which is why I went for Edinburgh Castle. And And the fortified point of entry is your deployment pipeline, because now you can do configuration as code. Now you can put all those changes through your pipeline. You should have all your changes going through your pipeline, so all the checks are in place. So that being said, you are going to need to have people to have direct access to production, which it's fine. It's just make sure you're using best practices around that, because the key thing with this type of environment is your supply chain doesn't end until you're delivering value to your users or your customers. So if you've got an API or a website, so this is still part of your supply chain. And if you have a production environment, there's one additional thing so this is Kubernetes stuff. I'm not very good at Kubernetes. I've never really worked a Kubernetes application, but this is interesting enough that I wanted to cover it in the talk. So the way Kubernetes works, and I'm going with AWS because I know AWS works, and this is very rough and ready. So, but the way it works is you have clusters, whether they're EKS or Google Kubernetes Engine clusters, that are basically collections of containers that are running in virtual environments. So, 10,000 feet view, but that's what's going on. Effectively, what this lets you do is you can have multiple production environments running, because they're all just collections of containers. So you can have say multiple versions of your application out and running in production. You can have versions for different time zones if you're expected to have your downtime at a certain time each day, regardless of where in the world it is. If you've got providing services to big ticket customers, you can give them their own environment to run against. You can do canary builds, loads of fun things you can do. The way this usually works mechanically, and again, AWS one, is that your build pipeline will actually push a container out to the Elastic Container Registry, and you will have deployment processes in place for pushing that code to particular clusters. You can hand roll your own with kubeconfig and kubectl, or you can use something like, for example, Spinnaker, which allows you to say, okay, take this version, put it out there. And that means you also have someone in there in your Kubernetes deployer group who is actually doing that. Take this version, put it out there, take this version, put it out there. Where this throws things into disarray a little in terms of supply chains and compliance frameworks is, where is your production deploy? Is your production deploy when a container goes into the Elastic Container Registry, or is it when someone uses Spinnaker to push a container out to one of your production environments? And there's no right answer there. The important thing is that you should have an answer actually defined, because you will need it for the auditors, and your processes need to be built around that. So if your production deploy is when a container goes into the container registry, then that means that you can only put stuff into the container registry that is production code. So pulling back, that is the pipeline, the supply chain really that we've been drawing out over the course of this talk. This is just an example. The fun thing about software delivery pipelines and software supply chains is every company's one is going to be completely different. And in fact, every application's one is going to be completely different. So you are going to have to apply your own thinking to your own chain. But the other thing to bear in mind is, as I referenced earlier, this is all running on infrastructure. So there is platforms that this is running in, and those platforms need to be treated like production platforms. So summing up very quickly, because I did this talk, I didn't have as much time as usual. There's some stuff in the summing up that isn't in the talk, but forgive me. The first rule of securing your software supply chain is to put security in your pipeline. And this is what everyone thinks of when you start chatting about DevSecOps and CI/CD with security and so on, is like having the right stuff to trust and verify all your sources. And as well, as I mentioned, like having a patching culture, having a security conscious developer culture really helps. The second thing is know what you're delivering. Be aware of what all your sources are. Be aware of what you're getting from those sources, and think in terms of software, so of the incidents as well as just the day-to-day delivery. The last thing is to think outside of your pipeline. Think in terms of the downstream applications from you and how you're going to verify what you're handing to them. Think in terms of the infrastructure your pipeline is running in. Think of your production environments as part of your pipeline. Last thing I want to mention is if you're looking for a good guide to all of this, I would point you to the NIST Secure Software Development Framework. This is the National Institute of blah, blah, blah in the US has put this together, and this is really good. This is basically a synthesis of different secure development standards that links out to all its sources. So it's a great jumping off point for reading material, but in and of itself, it's a fantastic collection of best practices, and here's everything you should be doing. And yeah, the other fun thing with it is that the US government is making this also mandatory for all its suppliers from next year. So it's another thing that if you're supplying code to the government, you have to be paying attention to. That is everything. There are my socials. There is my employer, Rapid7. We are hiring at the moment, and we have a placement student recruitment event on Thursday. So if you know anyone looking for a placement, then let them know to come along to the office. But we've got some time, I think, for a couple of questions. Yes. Sorry, could you wait for... Okay, well, in that case, I'll just repeat your question.
I'll just give it the best Brian Blessed I can do.
Yeah.
So a previous role I worked at, it was very, very results focused, and produced now you get a release, and there was absolutely, I couldn't, in all the time I was working there, get much or any buy-in for security, and certainly no funding for any tools. What would you, I mean, in the end I just left. What would you recommend doing in that sort of environment? Like,
okay.
If you came up against that.
Okay, well, I think like the question was in a environment where there isn't much buy-in for the concept of security in itself, what can you do to drive this type of thinking? I think what you need to do is, like, if you're selling this to your company's exec board, they're not thinking in terms of security, but they are thinking in terms of risk, reputational risk, and the commercial risk. And they're thinking in terms of what this will get them as well, what value they'll get from it. So in this case, your things like Log4Shell are actually really useful for this because they help you point to, look, here is the risk associated with this. If your company has compliance frameworks like ISO or NIST standards that it's signed up to, doing a gap analysis and saying, hey, so we're supplying to the US government. We're expected to be in line with this framework by next May. Here's everything we need to have in place to do that, or else we'll have to cut all those contracts. Like, a lot of that is like, this is more consultant thinking, is just put yourself in the headspace of the people you're trying to sell it to, and don't just try to convince them that security is virtuous. It is virtuous, but yeah. And as I said, like, the good thing is we are getting more of the customers are demanding we have these certifications. The suppliers are saying that the government are saying, hey, you must be in line with this, and so on. So we are at time, but I think I can take, if there's any more questions? No, that was it. Excellent. Well, thank you all. As I said, I'm the MC for the room, so I'll be in here all day, and I'll be hanging around if anyone wants to chat. There's a fantastic talk in here from Luke McNeice about hacking Furbies in 15 minutes. So look forward to that. And I'm sure the place will be absolutely packed out into the hallway for it. So thanks, everyone.